Hello everyone, this is Meysam Mehrawaran. I'm from Ozen Engineering and I'm trying to do a quick introduction to Thingworx for you guys today. What are we? What do we do at Ozen Engineering? We are a LA channel partner of ANSYS. We sell ANSYS products. We offer you support and training, and we do a lot of consulting works as well. Our simulation-driven product development tools are multi-physics finite element analysis, or FEA, computational fluid dynamics, or CFD, and also high and low frequency electromagnetic tools. And on top of that, the recently emerging the digital twin and IIoT-related software. We are the LA channel partner of ANSYS, and at the same time, we are a channel partner of PTC. On ANSYS side, we have a lot of structural and fluid and electromagnetic and also semiconductor and optics related to, simulation tools, as you see here. Also, we have tools for materials, also embedded software, systems, and 3D design. And on the PTC side, we have Thingworx and Vuforia, which is used for augmented reality. It's a big list of simulation tools, so if you're interested in any of these tools, you should let us know because they're pretty powerful and they can make your product development process much more efficient. To go through the agenda, first I'll have a quick introduction on Thingworx IoT, then I'll go over the wind tunnel deployment on Thingworx. After that, I'll focus on spiral coil deployment on Thingworx. Following it, I'll describe connectivity, specifically using Kepware server and how this connected to Thingworx. And at the end, there's a video to see how we set up the physical model and then also the digital twin and connected them together. And we can compare the results with each other. Industrial IIoT is transforming the business in the recent years. There's 5 billion connected devices by 2020. There's 43 zettabytes of data monthly by 2020, and also there is 72% of companies that agree digital business model is critical for success. So everything is going into that direction. These are from very reliable resources. On top of that, we have almost 47% of companies that believe traditional business models are not working in the future and they should kind of evolve by 2020, which is this year. And 79% of the companies see that the predictive and prescriptive machine maintenance as the #1 priority. I think on top of that, we can say that COVID has expedited the process because this digital twin and IoT and remote work and all those things have added up to that and made it more interesting. Can you afford to build your own platform? IoT platforms are quite complicated. You need to be able to resolve a lot of issues such as connectivity. You need to understand different protocols, different architectures. On top of that, you need to be good at network, database, analytics because you're connected to a large list of data and equipment, and it's quite difficult. You need different APIs and you need different applications for design and development, which makes the problem much more complicated. And after, even if you successfully created that, this question arises that is that scalable? Can it be extended? How does it adapt with different assets? What is exactly Thingworx Foundation? Thingworx Foundation is a process built for development of scalable and secure solutions so that it's simple to create and accelerate the time to market. And it's much more compelling. I will go through the details of it, what it can do and what it can't do in the next couple of slides. The Thingworx is based on the Thing model. Thing model is pretty much the cornerstone of all IoT platforms. As you see, it has a list of capabilities that they can be categorized, as you see in this picture. You see, we have a lot of applications, computers, devices, electronics, and all kind of assets. And then we have application enablement, which has several apps such as IoT data management, user interface builder, and you name it, all these top blocks. Uh, on top of that, you have the cloud compatibility, which means the device and the cloud can be connected, things can be deployed on the cloud. And also on top of that, there is edge, which means the interface between the devices and also the thing model. When you have a thing model, you can define properties, you can define services, you can define events, you can define subscriptions. And all these apps, of course, we can't sell it all as one product. So we categorize it and we sell each part which is connected to a certain capability as one product or sub-product. As you see, this is the Thingworx foundation. So all these apps are together. As I mentioned here, you can have properties, services, events, and also the subscription. So when you get the Thingworx foundation, you have all these capabilities. You can connect it to different devices, sensors, machinery, assets, and then try to understand it. On top of that, there is a bigger image of it that describes what PTC has in mind. For example, we have a lot more apps in this slide, as you see. We have some apps for asset management, for alert management, for software content management and workflow. We have apps for the thing model, which is the cornerstone, as I mentioned, which has data management and also system integration services, etc. We have devices which are mostly in charge of cloud deployment, which are in charge of big data and rules engine and file transfer and messaging and tuning and etc. Besides, we have the augmented reality tools or apps which can help you manage, let's say, a plant using AR. We have also edges like edge intelligence and SDKs and IoT gateways that I described before. They are coming as a part of the, I would say, the Thingworx foundation. And also we have analytics, which means that from all this data that you accumulate, how you can analyze, how you can make numerical or analytics driven decisions out of it. On top of that, as you see at the bottom, we have some apps which is related to industrial connectivity, such as data exchange and also communication platforms. The top apps, as you see here, are sold under the name of Thingworx Asset Advisor and Software Connect Management. The first top apps, top four apps, I would say. The right-hand side apps are sold as a part of Euphoria Studio, which at Ozen Engineering we are allowed to sell that product as well. On the left side, we have the Thingworx Analytics, which you have a lot of analytics capabilities and machine learning and trying to make sense of that ocean of data that you have. And also at the bottom, you have the Thingworx Kepware server, which gives you the ability to get connected to different industrial sensors, PLC controllers, etc. Using the Things model and Thingworx, you can connect to anything, especially if you have an edge device, you can be sure that it's consistent and connectable to all the devices you're dealing with. As you see here, when you have, let's say, a plant, you have a device, you have a car, you have a system or any kind of asset, you can connect them to a cloud and send the data to it. You can connect them to a gateway. You can connect them directly to the thing model, or you can connect them using embedded systems. But it doesn't matter. These edge devices that you have in your Thingworx are very compatible and very versatile. They can get data from pretty much every resources that you're dealing with. The other thing is that you can employ it where you need it. Let's say you have a model, you want to deploy it on Thingworx itself, you can deploy it on Microsoft Azure or Amazon or any other cloud and web services. You can even do hybrid, which means that you can deploy it on both at the same time. You can fully leverage your existing cloud or device connectivity investments, and it gives you the best-in-class security to monitor and interact with connected devices with high certainty. On top of that, you'll be able to integrate third-party applications in Snap quite fast, which means that if you have other tools like ERP, PLM, SLM, or other even analytics tools, they're totally connectable to Thingworx. In SQL, we're gonna focus on two projects that we did. One is a wind tunnel, which we deployed on Thingworx, and the other is the spiral. For the wind tunnel, the problem was a very small wind tunnel test that based on the voltage, you have a fan rotating and creating some wind, and that wind creates a lift force, and we measured that. So first we created a digital twin out of it. We built a model in FLUENT and created a response surface and reduce order model out of it. And we send the data from the power supply also to the twin builder, and from there we were able to calculate or predict the amount of lift force. And at the end, you can compare these data with each other. The next step was that we tried to modify the twin model that we had on the Thingworx. That was pretty straightforward. We had a batch file, and you can easily store your twin file and then deploy it on the cloud, so it's available. You can run it, you can get the data out of it. It has some steps which have been described in the slides as I show here, but we don't need to go through all of it. You create the analysis provider, and then you deploy it. And you create a template and thing and event so the data are connected, which means that, for example, based on the voltage, you'll be able to see what's the lift force. And as the last step, we need to visualize it. We need to have a human-machine interface that we call it here mashup. As you see, there's a mashup here. Based on that, you can read the voltage data, and you will be able to predict the amount of lift which is shown in the gauge here. This makes it very easy and usable for the customers. But under the surface, you see these are connected to your twin models, which is deployed on the cloud and is available on Thingworx. So whenever you run this or put the input on that, such as the voltage, it can predict the amount of lift force. The other problem that we're trying to solve was a spiral coil. It's a spiral coil that you have a current passing through it, so it heats up, so the angle that it turns changes, and also the temperature changes, and of course, because the resistance is changing, the voltage that you have on both sides of it would be changing as a function of time. We created a model of this spiral in mechanical, and then we create a ROM out of it. And again, similarly, we deployed on the Thingworx. Here is the whole setup. As you see, there is a power source or power supply similarly, and then this is a coil. We measure the angle, we measure the temperature, and of course, the measurement of the voltage is also already on the device, so we can see it. And this is the mashup we created for this problem. As you see, having certain amps, you'll be able to monitor the amount of volt, temperature, and also the degrees that it turns. The other important factor is the connectivity, which is mostly related to Kepware server and how it communicates with Thingworx. Connectivity is always quite complex. Different assets connect using different protocols, and usually it needs a lot of programs to learn. It's not always a one-step process. As you see, different machines and different environments use different languages, and sometimes it's hard to connect it all to IoT. And then after even making decisions, it's hard to connect it to the factory or the products to implement those data-driven decisions. It is much better to standardize the connectivity, which means that all the devices we are dealing with choose the same language. Then they would be able to easily transfer it to IoT, and then we can always try to send those data-driven decisions to our assets, which is like factory. It's very scalable. It's in standard tools, and it's very agreed upon data. It helps you make data-driven decisions pretty quick, and it's very secure too. What is exactly Thingworx Kepware server? It's a server, it's a device, it's like a hub that can connect to different kind of PLCs, over 150, I would say, drivers and advanced plugins, or any other devices or applications that you use in industrial automation. It's pretty much easy, like a plug and play. It has already the driver, and it can read different languages. Let's say you have the AB PLC controller or Rockwell Automation or Siemens or any other PLC and sensor. It can read those data, and then it can transfer it to either Thingworx or Azure or other IoT clouds, or even the on-premise apps like SCADA, MES, or anything else. So it's pretty much like a global language. It has the remote configuration. It has code-based trusted, which is trusted in over 75,000 industrial websites. And its connectivity to Allen Bradley control logics, which is a section of Rockwell and Siemens and Modbus and all other commonly used controllers. It's quite fascinating. For compatibility, I would say that Kepware is totally compatible with Thingworx. You can create a channel. You can create a channel for typical PLC controllers. As I said, you have all these list of controllers that you can just plug and play. It has the drivers already built in. You don't need to do anything extra. And then you can go to the Kepware, and if you go to the properties, they have a location for Thingworx, so you can just define the host IP address, and it's easily with maybe 4 or 5 other steps, you can connect them to Thingworx. So you'll have the live data from any kind of sensor or PLC controller or any other device that you have that can be transferred to your Thingworx model. Here we did the same thing. As this was the power supply, we connected them together, and then we had a driver, so we could read the live data on Thingworx. As you see, Thingworx reads the live data as we turn the knob and shows it here on the screen. And we connected that to our digital twin. This is a video of the whole setup while it was functioning.
Hello everyone, this is Maysam, and I'm going to have a quick demo for you guys on how to transfer the live data from our power supply to the digital twin, which has been already deployed on Thingworx. And based on that, approximate the value of the lift force and then show it in a mashup. We have a Siglum SPD1168X power supply, which can provide you voltage and also current. And we have connected that through an Ethernet cable to the back of the laptop or computer on your workstation you're working with. We need to transfer those data into Thingworx. In industrial applications, the software that they use for this purpose is called Kepware. As you see here, this is Kepware, and we need to first connect Kepware to our Thingworx. As you see here, when we start the Kepware, we define a host IP address, and then we connect them together. There's a little bit of setting in it. And then we create like a gateway between these two, so the Thingworx and the Kepware would stay connected. Kepware is a very kind of expensive software, but if you want to use it up to 1 or 2 hours, you can use it without any cost, and you don't need a license for it. Here, as you see, they are connected. And if you go to my quick client, we have set it up in a way that shows the data live from power supply into the software. For example, if you look at my power supply, I have 7.4 volts and 6.7 amps. If I turn it now, let's say to 6.6 volts and 6.7 amps, you see that the value changes live here, which indicates that the voltage and current created by power supply are available and transferred into the Kepware. And as I mentioned, Kepware is already connected to Thingworx via the property setup as I showed you guys here. So let's go to Thingworx now. This is Thingworx. So first we created an industrial connection, and we created a thing called SPD device because SPD was the name of the brand of the power supply we had. And we transferred the data from Kepware into this thing. It is shown here in these two names as you see here. The first one is the 6.7 amp, which is the current, and the third one, which is the last one, is 6.6 volt, which is the voltage. Now, if I play around with it and let's say make that voltage 6.7 to 7, and I refresh it, it would get updated, which means that you'll have the live data available. As I mentioned, we already have deployed our model, which was the model for a digital twin of a wind tunnel. We have the analysis providers, we have analysis models. As you see, it's this one, the twin model Maxwell 2, which is like I created that, it's already enabled. And then we also have the event, which is the first one, think Mason 1 fixed, which belongs to my wind tunnel digital twin. So it's already deployed, it's available. In the next step, we created a mashup. So we can visualize exactly how things are working and how we can calculate, let's say, the lift force as a function of voltage. As I mentioned, this is the thing that we have, and the digital twin has been deployed on it. So if you have the voltage, you'll be able to calculate the output lift force. And we have this SPD device thing, which shows the live data of current and voltage from the power supply. And on top of that, we need this mashup. This mashup is just one monitor which shows the amount of voltage we read from the power supply through Kepware. And also it has the gauge that shows the amount of lift force, and refresh that updates it, and it's invisible so you don't see it. So if we deploy it, this is what we would get. As you see here, I have 7 volts, and you see that it's live, it's connected to the power supply, and it shows exactly what I have on the screen. And based on that, it calculates the amount of lift force. Now, if I change it, let's say, to 8 volts to get the gauges and the values that it shows. If I change it manually to 8, you see, it became a little larger value. If I make it, let's say, 9 or 10, I'll make it 10, for example. You see, at 10 volts, so the value of the lift volts also increased and updated. So in this demo, we saw that we could bring the live data into the called Kepware, and from there into Thingworx. And based on the Hypno digital tune, you could predict the output based on that. Just to note, the gauge that shows the lift moved a little slower because there is a time response limit in Thingworx, so you can't make things happen faster than 1 or 2 seconds in some cases. But as you see now, it's 10-volt fixed, and the gauge is also not moving. Thanks for your attention, and have a great rest of the day. Goodbye.
And thank you guys for listening to this seminar. And here's the information. If you had any questions, feel free to ask us, email us. And if you had any questions about the softwares or consulting or anything else, don't hesitate to shoot us an email or give us a call. Thank you and have a great rest of the day. Goodbye.